All right, so I want to go over some applications and word problems that you might have that would make you create an equation in order to solve them. Some of these can be solved just by trial and error, but really one of the beautiful things about algebra is that it allows you to be able to create an equation and solve it and not have to guess and check, which in the long run will save you a lot of time. So let's look at our first example here. You've got 4 consecutive integers sum to 38. What are the integers? So what this is saying here is that you have 4 numbers. Integers are like, whole numbers. So they can also be negative. They might be negative. So we're looking at like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up forever. And also all of the negative whole numbers. So -1, -2, -3, so on and so forth. So we have 4 consecutive. Consecutive just means one after another. So for example, I don't know if this is the answer, but 4, 5, 6, and 7 are consecutive integers. Now, those don't sum to 38. Those sum up to 22, I think. So that would not be the answer, but those are 4 consecutive integers. So the idea here is that you've got something, 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 and something. And the second something happens to be one more than the first something, and so on and so forth down the line. The third one is more than one more than the second one, so on and so forth. So how should we take that information? How could we maybe create an equation that would solve this? So what I would recommend is I'm going to make the first integer x. I don't know what the first integer is. I'm just going to call it x. In that case, what would the second integer be? If the first integer is x and the second integer is one more than the first integer, couldn't we just call the second one x plus 1? And then using a similar argument, we could say that the third integer is, one more than x plus 1. How do we write 1 more than x plus 1? How about x plus 2? You could say x plus 1 plus 1, or you could just say x plus 2. How about the fourth integer? What's the fourth integer in terms of x, right? So it would be x plus 3, because it's 3 more than that first integer there. And so now what we've got is we have 4 integers. We have written x for the first one, and everything is in terms of x. What we're going to do is we're going to take these 4 numbers and add them up, and in theory it should sum to 38. So sum just means add, so it should add up to 38. So we're going to take the first integer, and then the second integer, and then the third integer, and then the fourth integer, and altogether those should add up to 38. I put them in parentheses here. You don't have to put them in parentheses. Sometimes the parentheses are just nice so that you can see that certain things are grouped together. So now we can just solve this, and these aren't too terribly difficult to solve usually once you get them set up. I find the hardest part is just setting them up. All right, so let's look for some like terms here. I got 1, 2, 3, 4 x's. So 4x. And then numbers wise, I have 1 plus 2 is 3. Plus 3 is 6. So 4x plus 6 equals 38. And we'll just solve from here. So subtract 6 on both sides. 4x must be 32. And divide by 4 on both sides. So x must be 8. So what was the question asking? Okay, so we've solved for x, and be careful here. Usually I get really excited when I solve for x. I'm like, oh, I have the answer. What are they asking for? They're asking, what are the integers? So what do you mean integers? Well, it says there are 4 of them. So that means that our final answer, if we found x, what is x? If we go back to the original thing we set up here, x was the first integer. So that means that the first integer is 8. The next integer must be 9. Then 10, then 11. Those are the 4 integers. And you can double check and add those and just make sure that they equal 38, which they do. All right, let's try another one. All right, so let's try this one. So you have 4 consecutive odd integers summed to 72. What are the integers? This is very similar to our last problem. The only difference here is that we're dealing specifically with odd integers. And so let's think about this. Let's make our first integer x. And now the only thing that's going to be different here is our second integer is not going to be x plus 1. I want you to think about this for a sec. I'm just going to write 4 consecutive odd integers. So 3, 5, 7, 9. Those are 4 consecutive odd integers. Some people argue, wait, 5 doesn't come right after 3. Well, it's the next odd integer after 3 because 4 is even. So in that sense, they're consecutive odd integers. Okay, obviously these 4 don't add up to 72, but that's an example of 4 consecutive odd integers. My question is, how do we express the second integer right here, which is 5, in terms of the first integer? Or in other words, how do we express 7 in terms of 5? How do we express 9 in terms of 7? I'm going to say that whatever the next integer is, the next odd integer, I should say, is always going to be 2 more than the last one. So the second integer, whatever it is, in our case here, it's 5. 5 happens to be 3 plus 2. The third integer is going to be 2 more than the second integer. So if you take x plus 2 and you add 2 to that, you should have x plus 4. And this makes sense if you look at the third integer, 7 versus 3. 7 happens to be 4 more than 3. What should we put for our fourth consecutive odd integer? I'm going to say x plus 6 because we have to be 2 more than this one right here. And now we're just going to approach it the exact same as we did the last problem. We're just going to add up all of our integers and set it equal to 72. So x is our first one, x plus 2 is our second one, x plus 4 is our third one, and then x plus 6 is our fourth one. Apparently all these together must be 72. Okay, so how many x's do we have here? 1, 2, 3, 4. So we'll say 4x. And then what are we dealing with numbers here? We got 2, 4, and 6. If you add 2, 4, and 6, that would be 12. So 4x plus 12 must equal 72. Now we're just solving. So subtract 12 from both sides. You'll have 4x equals 60, and then once you're here, since you're multiplying by 4, you divide by 4 on both sides. And the 4's go away, so you'll have x is equal to 60 divided by 4, that's 15. All right, and is 15 the answer? Well, what was the question asking? The question was asking what are the integers, so there are multiple integers. We solved for x, which happens to be the first integer. So our answer then would be 15, 17, 19, and 21 because we have to take 4 consecutive odd integers. Okay, and if you check and you add those, they equal 72. All right, number 3. The length of a rectangle is 3 more than twice the width. If the perimeter is 54, what are the dimensions? So I always have students who read problems like this and they freak out. They're like, I don't know what to do. And I say, well, if nothing else, at least draw a picture, right? Like, I'm hoping that at this point in your high school career, you know how to draw a rectangle. Okay? So don't just give up too easily. You got to put up a little bit of a fight. So let's do a rectangle here. And, okay, so the length is 3 more than twice the width. So generally with rectangles, we consider this the width and this the length. The length is usually the longer of the two dimensions. Okay, so the width I don't know, the length I don't know. So what I'm going to do is I'm going to call the width x. Some people call it w. That's fine. You can call it w if you want. You'll get the same answer in the end. Okay, so the width is, I'm going to call it x. And now it's saying the length, which is right here, is 3 more than twice the width. So if the width is x, I'm going to say twice the width would be 2x. And if you take 3 more than that, then you're dealing with 2x plus 3. That's how we can express the length as a function of the width. So here's the length, here's the width. What's nice here is that they both have x in them. Okay, what else do we know about this rectangle? So let's just keep rereading. A lot of times I just keep rereading problems to see if I can gain some more insight or get an idea. The length of a rectangle is 3 more than twice the width, so we've input that information. If the perimeter is 54, what are the dimensions? So they just want to know what the width and what the length are, but there is this piece of information right here, namely that the perimeter is 54 that we haven't really used yet. So how are we going to deal with that? Well, the perimeter is if you add up every side. So if you took this x right here and this 2x plus 3, and you took whatever this is, and you took whatever this is right here, theoretically that should equal 54. The only issue here is that we don't know what this is and we don't know what this is, except for the fact that we're dealing with a rectangle. So if you have a rectangle, you know that the width is the same on both sides and the length is the same on both sides. So now we've got a situation where we know all 4 sides. Well, we don't know what they are, but we know how to express them at least. All 4 sides, and we know that they have to equal 54. So let's just do that. So let's do x plus 2x plus 3. Again, you don't have to use parentheses here. I just like to do it for grouping. So I've got the width, the length, and the length. And altogether, that's going to be 54. Now we're just solving. Okay, so 1, 2, 3, 4, 5, 6. So we have 6 x's. And then we're dealing with 3 and 3, so that makes 6. So 6x plus 6 must be 54 here. So if we subtract 6 from both sides, then we've got 6x is equal to 48. Divide by 6. And we have x must be 48 over 6 is 8. Okay, so x is 8. Is that what they were asking for? Let's not get too excited. We might not have the answer quite yet. They want to know, the question is, what are the dimensions? So we know x is 8, but what was x originally in our diagram here? X was the width. So that must mean that the width is 8, and then we also need to supply the length. So the length is, how would we find the length? If we know the width is 8 and we know the length is 2x plus 3, then let's just actually, if we know x is 8, then 2x plus 3 must be 2 times 8 plus 3. So 2 times 8 plus 3 is 16 plus 3 is 19. So the length is 19. You may ask yourself, I wonder if this is right. Well, this is what's really nice about algebra. You can check it and see if it's right. Check and verify that 19 happens to be 3 more than twice 8, which it is. And then what you should do is build a rectangle, make the width 8, and then make the length 19, and just check and make sure that the perimeter is 54, which if you did that here, it would work. Okay, number 4. If f of x is equal to 2x minus 3 times 4x minus 2, and f of x is negative 54, what is x? This one's actually not terribly complicated, but I just wanted to show you an example of something like this. So basically what's happening here is, if you go back and think about what a function is, this is the output of the function, and this happens to be equal to negative 54, right? This is saying f of x, this is f of x. So in other words, this thing must equal this thing right here. So we're just going to do that, set those equal and solve. So we'll say 2x minus 3 times 4x minus 2 is equal to negative 54, and we're just going to solve. I generally recommend distributing here if you've got some stuff to distribute. Again, there are like millions of ways you could solve this problem that are all equally valid, but I'm going to multiply here. So negative 3 times 4x, so I'm going to do this distribution here first. That's going to be minus 12x. And then when I do negative 3 times negative 2, that gives me positive 6, so plus 6. And at this point, I'd probably simplify the left side a little bit. So 2x minus 12x would be negative 10x. Plus 6 is negative 54. And now we're just solving, so we'll subtract 6 from both sides. And we'll have negative 10x equals negative 54 minus 6 would be negative 60. And now we're going to divide by negative 10. Be careful here. Don't add 10. These things are being multiplied. It's negative 10 times x. So we're going to divide by negative 10. Because division will undo multiplication. All right, so we're left with x is equal to negative 60 divided by negative 10. That would be positive 6. Is this what they were asking for? Yes, it is. It says, what is x? The directions say, what is x? So we can just say, hey, x must be 6. And we're done. Number 5, in an isosceles triangle, yep, you're not done with geometry just yet, the base is 4 less than twice the length of one of those legs. If the perimeter is 44, how long are the legs? So, first thing you need to know is what an isosceles triangle is. So, I'm going to draw a triangle here. An isosceles triangle is where a couple of the sides are the exact same length. I've marked them with, I call these hash marks here. So, they both have a double hash mark, which means that this side is the exact same length as this side. That's what an isosceles triangle is. It's a triangle where two of the sides are the same length. Okay, so these are called legs. So these are called legs right here, these two sides. And then the base is this third side here. Okay, all right. So now that we've remembered what an isosceles triangle is, the base is 4 less than twice the length of one of the legs. So what I'm going to do is I'm going to call the legs x. They're both x. I can label them both x because I know they're exactly the same. I don't know what x is, but if one thing is x and it's equal to something else, they must be x. Okay. The base needs to be 4 less than twice that length. So let's do twice that length, and then if you do 4 less than that, you should have 2x minus 4. Be really careful. Some people are tempted to write 4 minus 2x because they see 4 and then they think that means less than twice the length. Don't do that. This is way wrong. Okay? You want to think about it. If you are 4 less than something, then you have that something and you must be subtracting 4. Okay, whenever I solve problems, I'm always like, wait, okay, where am I? What am I supposed to be doing? Okay, how long are the legs? So right now I'm trying to figure out how long these two sides are here. Okay, that's my goal. What else do I know? All right, it's an isosceles triangle. We got that. The base is 4 less than twice the length of one of the legs. We got that. Here we go. We have not used this information yet. The perimeter is 44. Would that be helpful? Absolutely, that would be very helpful because what we're going to do is we're going to say that when we add up all of the sides, which we have an expression for all the sides. We don't know how long the sides are, but we know, hey, one of the sides is x, the other side is x, and then the base is 2x minus 4. Those are all the sides. When we add them together, theoretically, they're 44. And now we're just doing some algebra. So x, 2x, that makes 4x. And then minus 4 is just minus 4. That's equal to 44. And now we're just doing some algebra. So we'll add 4 to both sides. And now we've got 4x must equal 48. And we'll divide by 4 on both sides. So that means x will be equal to 48 over 4 is 12. Let's see. I'm going to box that in. Is that what they were asking for? If the perimeter is 44, how long are the legs? We found that x was 12. Hey, look at that. So x actually is the distance of one of the legs. So if you want, you can just promote that from dashed line to solid line. That must be the answer. The legs are 12 long. All right, last one here. So this one is the formula for converting temperature from Celsius to Fahrenheit is F is equal to 9/5 C plus 32, and that's actually correct. If you think about when water boils at normal atmospheric pressure and all that fun stuff at sea level, Fahrenheit, it is about 212 degrees, and Celsius is about 100 degrees. So it's funny, if you actually plugged in 100 here, you would take 9/5 of 100, and that would give you 180. and then you add 32 to that, that would give you 212, which is exactly the temperature at which water boils for Fahrenheit. So it's kind of cool. All right, using this, and by this, they're referring to this little equation here, figure out a formula that converts temperature from Fahrenheit to Celsius. So what this does is it takes a Celsius input and it calculates Fahrenheit. You can kind of think of it as a function. So you have f of x equals, something over here. So 9/5 x plus 32. So basically what's happening here is this right here is the input, which we put in right here, right? This is the input. Overall, this whole thing right here is the output, which is the Fahrenheit. So what we're doing is we put in a Celsius number and we get as the output a Fahrenheit number. All they want you to do is figure out, what if it's the other way around? What if I put in a Fahrenheit number and I want to get a Celsius output? Theoretically, if you knew the Fahrenheit number, you could just plug it in here and solve for C. But what they're asking you to do is figure out the general formula first, and then we can just plug in numbers real quickly. We don't even have to think about it. Okay, so let's actually take that equation, f is equal to 9/5 c plus 32, and the goal here is at the end of this to have something that says c is equal to, something over here. We're going to write something in this spot right here. Something that involves f. It's probably going to have 32 in there. It's probably going to have 9 and 5 in there somewhere. But that's the goal, okay? So really, basically all this question's asking is just to solve for c, if you want to boil it down. Pun intended. All right, so if we solve for c here, then I'm going to recommend that the first step that we do is to subtract 32 from both sides. You are more than welcome to multiply everything by 5 if you'd like. Some people do that because they see the 5 here and they're like, I hate fractions. You can do that. That's totally fine. You'll get the same answer in the end. I'm going to subtract 32 first. That's just me. So on the left, I get f minus 32. On the right, those 32s go away. So I'm just left with 9/5 c. And so I'm trying to get c by itself. So what I'm going to recommend here is that you multiply by, okay, there are a couple options here. You can either multiply by 5 or you can multiply by 5/9. I'm going to recommend multiplying by 5/9 because it saves us a step. Basically, if you multiply it just by 5, what you're going to do on the next step is divide by 9 because you're going to be left with 9c is equal to, 5 times f minus 32. But if you'd like, if you ever want to get rid of a fraction, you can multiply by its reciprocal. Just flip the fraction and multiply. If you think about this, 9 times 5 would give you 45. 5 times 9 would give you 45. So essentially you have 45 over 45, which is 1. So those will cancel each other. I have multiplied by 5/9 on the right. I should do the same thing on the left here. Please, please, please put parentheses around the left thing. The f minus 32 needs to be in parentheses. You can't just multiply f by 5/9. The entire left side, including the minus 32, needs to get multiplied by 5/9. Okay, so let's do this. So on the left, we're going to have, let's actually multiply this out. So we're going to have 5/9 f minus, oh gosh, what's 32 times 5/9? 32 times 5 over 9. That's going to be 160 over 9. Yep, let's just leave it like that. Minus 160 over 9. And that's equal to c because the 5/9 and the 9/5 multiply to make 1. Okay, so this is actually your answer right here. And let's just rewrite it with c on the left. So we have 5/9 f minus 160 over 9. So if you ever know the temperature in Fahrenheit and you want to figure out what it is in Celsius, this is your formula right here. You could use this. By the way, if you have done this problem and you've done it slightly differently, and you have an answer that is c is equal to 5/9 f minus 32, that is totally valid. That works as well. You just didn't multiply the 5/9 out, and that's fine. Either one of these is fine.